between the two core switches. Okay. Fast Ethernet 1, Fast Ethernet 1, and Fast Ethernet 2, Fast Ethernet 2. Right? You're going to see these come up kind of slowly. What's happening is the switch is negotiating with Spanning Tree Protocol in order to establish the link. Okay? Now, again, all this is happening at layer 2. So there's no IP addresses that are being exchanged. The only thing that is happening, and this is a complete what we call a flat network, there's only one VLAN in play right now, VLAN 1. Okay, VLAN 1. We've not made any additional VLANs. We've not told the switches anything. Nothing at all. Okay? So, that said, if I were to plug some in devices up here, say like a generic laptop, there, and generic laptop here, just, connect a couple of them up. Once I plug those in, and once the Ethernet protocol comes up, negotiates the connection, establishes the connection, they all green up, so to speak. Here a second. Here it goes. All right. You can configure the settings. Here we go. Go to the Fast Ethernet. Let's just give it a static address of 10.0.0.100 and a 24-bit subnet mask. IPv4 has its own MAC address, right? Physical, desktop. This is actually kind of cool. Right? And then I can bring up a command prompt, and I can ping my own address. And you can see that I can ping myself, right? Nice little handy-dandy little tool. So that's laptop 0. I'm just going to minimize that. Let's go over here to laptop 1. Put it on the same network. On the same network. So this time I'll go to the desktop and I'll hit IP configuration. And I'm going to make him 10.0.0.200 in the same subnet. default gateway needed, nothing. I'll bring up his command prompt. I'll ping myself, and now I can ping it. Now, going back to the topology, since all these switches are connected together and they're all in the same VLAN, they're all sharing the same spanning tree. Okay, they're communicating with one another and establishing MAC tables on an individual basis. I should be able to ping between the two devices. And I can. Right? I can. All right. So now let's have some fun with VLANs. Right? Let me go over to switch number 1. So it looks like I put that laptop on 24. So I'm going to configuration mode, and I'm going to go into interface fast Ethernet 024. That's where I connected that laptop. Okay? And from here, I can do a couple things. Now, with the newer style switches, I can change VLANs at the interface level. If that VLAN is not defined by the switch, it's smart enough now that it will recognize that and go, oh, there's not that VLAN, so I'm going to make one. I'm going to make one right now to do that. Okay? So if I come on here and I go switch port, which is the main command to do anything on a port at layer 2, I have to tell it what mode it's going to be in. And I could be in 3 different modes: access, dynamic, or trunk. Okay? Now, you never, hardly ever use dynamic, ever, at layer 2. Okay? You either use access or trunk. Here's the difference between the two. An access port is connected to an end device. An access port is connected to an end device. A printer, a PC, a laptop, an access point. I can go on and on. A trunk port is connected to another switch. Alright? And here's how you really keep it straight in your brain. An access port is one VLAN. Typically. One VLAN, and one VLAN only. A trunk port can be many VLANs. It could be hundreds of VLANs. They all share that information between them across that channel. Okay? Now, here's what I mean when I say typically for an access port. Okay? I can do this. I bring an IP phone up here. I can connect it to another port. Say I want to see how it has 2 ports. I can connect it into that switch, say at fast Ethernet 01. And I can bring yet another end device, say like a PC. Then I can connect that PC from its fast Ethernet into the IP phone. A lot of IP phones, it doesn't matter what manufacturer, Cisco, Avaya, Polycom, 3Com, doesn't matter. A lot of them have an integrated switch on the back of them. So you plug the IP phone into the network, right? And it goes back to the switch. But then you can take a PC or a laptop or some other device and plug it into what is called the PC port on that phone. So what did I just do? If you're talking about a structured environment in a business or school or hospital or whatever, what did I just reduce? number of lines that you have running to that station. Right? The number of lines, the number of ports that you have to have, right? So here's that exception. Here's that exception. You still make this port on this switch an access layer port if you're running a Cisco environment. Because the phone will use Cisco Discovery Protocol, which is a proprietary protocol, to communicate to the Cisco switch and tell it, I have another device hooked up behind me. Okay? I'm an IP phone. I need to use the voice VLAN. The device that's behind me is going to use whatever VLAN that is assigned to your port. And then the phone and the switch negotiate this. Now, if this is another manufacturer switch, Extreme, Juniper, 3Com, etc., or if this is another manufacturer's phone and this is a Cisco switch, this has to be a trunk. This has to be a trunk. Because you cannot use Cisco Discovery Protocol to negotiate that. Okay? That's not going to be on the test or anything. That's not going to be quizable or testable. But it's very important that you understand that when you go out and you talk about networking or you interview for a job or people ask you questions, you kind of understand how it all works and it all fits together. Okay? So, what do I do? On that fast Ethernet port 1, take a note of this, you will see it again. Int F0/1. I do want to make it switch port mode access. Alright, now for giggles, let's say that the PCs are going to be on VLAN 10 and phones will be on VLAN 20. Okay? So let me write this up here. So PCs, laptops, VLAN 10. Phones, VLAN 20. Okay? Everybody with me? So, PCs will talk to one another. The phones will talk to one another, but they won't talk together. And we've already established that the PCs are on 10.0.0.0/24. Let's put the phones on 192.168.0.0/24. So it's glaringly obvious, you know, that there's a difference. Okay? Everybody with me? All right. So this switch port has to talk to the PC as its primary VLAN. Switch port, access, VLAN 10. See, now I did not do anything, but the switch will say, hey, that VLAN does not exist. I'm going to make it for you. Really nice, cool little extra step that you used to have to do on your own that the switch will do it for you now. It's not created. Okay. And then in order for the switch port to talk to the phone, switch port, access, switch port, voice, VLAN, and the VLAN number. Ooh, it didn't create VLAN 20 for me though. It did not create VLAN 20 for me, and there's a reason. In order for you to make a voice VLAN, you have to input it yourself. So, to create a VLAN in a switch, alright? There's a couple different ways you can do it. Alright? You can type VLAN, the VLAN number, from global configuration mode. You can exit out of global configuration mode, and you can go directly into the VLAN database, and you can enter it there. Okay? 6 in one hand, half a dozen in the other. It does the same thing. Okay? Like with many things in programming. Okay? Like with many things in programming. Right? You can make loops a couple different ways. You can do calls. You know, make object identifiers a couple different ways. Same thing in Cisco scripting. Okay? Cisco programming. You can do things a couple different ways for certain things. VLANs is one of them. So I'm just going to go into global configuration mode. VLAN 20. I'm now in the VLAN. Now I can do stuff like, give it a name, negate it. It doesn't give you all the other information, but the primary thing is, let's give it a name. Name, voice. If I do a show run, you now see that port is created. Okay? Now let's go back to our topology. Now that I've changed that port on that switch to VLAN 10, let's go back into the laptop. Right? Oh, you lie. You're not supposed to work. That's not very fair. It's not supposed to work. When you segregate different VLANs off, right? So I have, this is one thing that doesn't work. Since I changed, I take that back. I did that wrong. I know what I did. Wrong port. So let's go into this PC. I missed one thing. Let's make him the PC 10.0.0.201. Okay. So I can ping myself. Go back to laptop 1. Now let me try to ping 201. I can't. It times out. That's because this PC is on a different VLAN than this laptop and this laptop. So now, let me go back down here to switch 1. And he's on, looks like he's in it too. Ethernet 2. So let me go into this and Ethernet 2. Fast Ethernet 02. And let me put this PC or this laptop on VLAN 10. Switch port, mode, access. Switch port, access, VLAN 10. Alright, good. Now, if I go on the laptop, alright, on 100 I believe down here. Well, yeah, on 100. Now if I try to ping 200, oh wait, I can't ping 200. Alright, well maybe I can ping 201. Nope. topology. What am I missing? Anybody know? So, put this guy in VLAN 10. Put this guy in VLAN 10. They should be able to ping one another, right? They can't. There's a reason. Look at the two core switches. Look at the two core switches. There's a link between the two of them. I did no programming on those switch ports whatsoever, so by default, what are they? Are they access ports or are they trunk ports? No, they're access ports. They're access ports. By default, they're access ports. That means they're going to be in the default VLAN, which is VLAN 1. They have no clue about VLAN 10 or VLAN 20. No clue about VLAN 10 or VLAN 20. So, in order for me to get this to work, I can do one of two things. I can change these two ports to VLAN 10. I'll bring it up. Easy. But what would be better, since I'm working in a multi-VLAN environment, is to make this a trunk port and add VLAN 10 and VLAN 20 to it. Add VLAN 10 and VLAN 20 to it. Because I might add, you know, more phones down here that need to talk to one another, etc. Okay? There's a couple schools of thought here. One, you can set up your trunk to accept all VLANs. You know, thousands of VLANs. All right? Which is okay, it makes life a lot easier for you, but it also increases your overhead, your memory, and it's not a really good security practice. Or you can manage it from a standpoint of, oh, I'm only going to add the VLANs that I need when I need them at the time I need them. That's the better practice to do. So, just quickly, we get what ports what? Gig 1, gig 1. All right, good. So, here's how you create a trunk port. First off, I'm going to create VLAN 10 and VLAN 20 on both switches. So, I showed you how to do it from global config mode. Now I'm going to show you how to do it from the VLAN database. Alright? A lot of times you'll get this message. Alright? All you have to do is go into the VLAN database. You see that the config prompt changes. VLAN 10. I can stop there or I can give it a name. I'm just going to stop there. And then VLAN 20. Now I gave VLAN 20 a name. It was called voice, right? So I can name it just like that. And I'm done. Let me do the same thing real quick on switch 1. But from the more traditional way to do it. Alright? VLAN 10 and VLAN 20. Up. Exit. VLAN 20. And then name voice. Just like that. Now I need to go to the gigabit port on each of these. G, I think it's 1/0. G0/1. There we go. Okay. Now, I need to change the mode of the port from access to trunk. I need to tell the trunk what VLANs to accept. So, switch port, mode, trunk. Okay. And it gives me an error. An interface whose trunk encapsulation is auto cannot be configured to trunk mode. So I have to change the framing type. The framing type. So, switch port, trunk encapsulation is the command. And it's only going to allow you to do .1Q, which is what standard? Anybody know? You studied it. What's .1q? What type of layer 2 protocol is that? 802.1 is Ethernet. All right. Now I can run the switch port. God, I'm lazy. Up arrow, there. Now I can move the. Ooh, that doesn't look good. It bounced the interface. That's all it did. Now I want to add the VLANs, which is the command switch port, trunk, allowed, VLAN, add. I want to add a VLAN to the list. 10, comma, 20. It's going to make me do them individually. 10 and 20. All right. Go back to switch 0 and do the same thing. All right, so there's a way around this. By default, a router or switch, when you mistype a command, we'll try to look that up through a DNS search. To get around that, just as a recursive, no IP domain dash lookup. And I'll get rid of that from ever happening again. No IP domain dash lookup. So on switch 0, I need to go to gig 1 interface G0/1. Switch port, trunk, encapsulation, .1q. Switch port, mode, trunk. Switch port, trunk, allowed, VLAN 10, and I do show run. I goofed. Switch port, trunk, allowed, there we go, 10 and 20. I want to make sure that that matches up with it didn't take. So, switch port. match up. So now that trunk has both those VLANs. Got another problem. This is all VLAN 1. This is all VLAN 1. So I also have to do the same thing on these ports here. On these ports here. Capacity net 01. And capacity net 01. That's down the multi-layer switch. I come down here on the. You see how you lose connectivity? I'll come back in a second. Now, I did not have to do that on the layer 2 switch because I did not have to define the Ethernet protocol because it's done by default. That's back up, and that is a trunk. I can ping that PC. So, the moral of the story, ladies and gentlemen, is when you are connecting up switches together, by default, they're going to be access ports, and they're only going to recognize one VLAN. Typically, VLAN 1, which is there by default. It's also called your native VLAN. All right? If you are working in a complex layer 2 environment, meaning you have multiple networks at layer 2, multiple networks at layer 2. All right, you're segregating your traffic. You've got to set up trunks between your switches. You've got to set up trunks between your switches so that they recognize that there are multiple VLANs. Now, every time I put a VLAN in here, it creates another instance of spanning tree. We talked about spanning tree a little bit a few classes ago. And that's the protocol that prevents loops from happening at layer 2. Okay? You guys recall. It prevents loops from happening at layer 2, especially when you connect switches up together. So if I were to connect up, this switch over here, this switch over here, this switch over here, okay, it would prevent a loop from happening, frames just going, willy-nilly across the network. Okay? It'll block ports and allow ports and forward ports and all that cool stuff. Okay? When you have an environment where you have IP phones, okay, typically in a single provider network, like a Cisco network, this will still be an access layer switch, and you just define the voice VLAN as an afterthought in the port configuration. In a non-Cisco environment or a multi-vendor environment, this will have to be a trunk as well, because it needs to support the VLAN that the phone's on and the VLAN that the PC's on. Now, a lot of time, a lot of junior engineers or not so seasoned or experienced engineers, admins, will keep this an access port and make the mistake of putting the phone and the PC on the same network. And then they'll ask the question, why does my voice network suck? Why do I have choppy voice when I, go and play YouTube? Okay? It's because there's no QoS involved. There's no QoS involved. All right? And that's handled here at the switch as well. Okay? And there are other commands that you can do that we'll get into in 347. We talk a little bit about voice more in depth. Okay? That you can do. You're going to see, for those of you who are in 347 next quarter, you're going to see a lot more of this. We're going to really play hard in the Layer 2 sandbox. For the test, though, for your final, what you're going to have is you're going to have what you've had before on Test 2, Lab 4. For the most part, you have a routed environment. And I'm going to break that routed environment down to something of this nature. 2 switches that you have to trunk, and instead of having all this here, I'm just going to have maybe a laptop or a PC down there. Now, here's the good news. When you come to your final, and we'll go over this a little bit more on Thursday because we have another day to do some more review and work on it. And I'll have a couple of exercises for you that you can get a little bit better at this. I'm going to have a packet tracer file that I'm going to upload to Blackboard. So it's going to have some of your environment already there. It's going to have some of your environment already there. So you're not going to have to drag switches and routers and do all that stuff. I'm going to have your physical environment for you. I'm going to have your physical environment for you. I'm even going to have most of it connected. You're just going to have to program everything. You're just going to have to program everything. So you'll have that file, and you'll have the test, the Word document as well, okay, which will have a snapshot of the a Visio of the network. Okay, and then your 10 questions. Okay, so you'll have something that kind of looks like this.